Okay, we are in the part 4 here of section 7.4, where we are looking now at how to add and subtract rational expressions. And this is going to be section 7.4, part 4, part 4, and this is going to be type 3. So I think when you see these types of problems, everything I was trying to say before should crystallize. But you have to see all the parts of this, kind of like a puzzle, to see the complete picture for what to be looking for when you are trying to add and subtract rational expressions. Because this is among the more confusing topics when students are working on these types of problems. So let's go forward and let's go ahead and take a look at some examples. Some examples that perhaps aren't too difficult to do. So we're going to start with question 8. And this is going to be 4 over 9t minus 7 over 6t. So we're going to begin with something fairly simple and straightforward. What I'm going to go ahead and do is I'm going to, and in this one I think I'm actually going to use a different color marker on this to kind of illustrate the point, or maybe a different color pen. Hoping that will show up nicely and kind of illustrate the differences here. What I will do is I'm going to go ahead and I'm going to rewrite this problem with the factors in the bottom. So 9t I can write as 3 times 3 times t minus 7 over 2 times 3 times t. So what we have here when we look at the denominators of these problems is we have a t that's in common. I don't know if that shows up well. Let's try something. Let's try pink. Well, it's my wife's marker, so yeah, I think they'll show up better, contrast enough. So we have a t that's in common. We have 1, 3 that's in common. But now each denominator has another factor that's not in common in the other one. So this one has a 2, this one has a 3. So what's going to happen with this 2 here is I'm going to multiply the top and bottom of this by 2. What happens with this 3 here is I'm going to go to the other fraction and multiply the top and bottom of this fraction by 3. So it's when the denominators of both fractions each have uncommon factors that establishes what we're going to multiply each fraction by. You may have learned this technique, or you may have learned something different when multiplying regular fractions, but this is the technique we're going to be applying here. And if it's a little vague with just the numbers, it should become increasingly clear as we begin to work with doing this technique with binomials. We'll be doing several questions in this particular video on this section here. So let's go ahead and multiply. We're going to have 2 times 4. That's going to be 8 over 2 times 3 times 3 times t minus 7 times 3, which would be 21, over 2 times 3 times, and I'll put the 3 here, times t. Because I have the same denominators, I can just go ahead and write this as 8 minus 21 over 2 times 3 times 3 times t. And then 8 minus 21 will give us negative 13 over, let's see, 13's prime, it's not going to reduce to anything, so let me just clean this up. 2 times 3 is 6, 6 times 3 is 18, and 18 times t is going to give me 18t. So here is my final answer, expressed in simplest form. The big takeaway from this is that we have to identify all of the factors in each denominator, see which ones are like, and then identify the ones that are not like so we can multiply the other fraction by them. This is the big takeaway from this section. We're going to offer lots of examples to reinforce this concept because these are the most common type problems you can encounter. So we'll go forward with another question here, one involving just numbers before we go to the more deep level stuff. This is going to be question 14. This is going to be x plus 5, x plus 5 over 8 plus x minus 3 over 12. Again, here what we're going to do in this question is we're going to rewrite the denominators in their prime factored form. So I'm going to write, let me do this over here, x plus 5 over 8 is 2 times 2 times 2. You can do that with a factor tree as I've shown in previous videos. Plus x minus 3 over 2 times 2 times 3. And yes, I can do these all in my head. I've taught this for several years. So what do? I look in the denominators and identify prime factors that are uncommon. 2, 2. And here we have a 2 that is not in common with the other denominator. Here we have a 3 that is not in common with the other denominator. So I'm going to take the 3 not in common here, and I'm going to multiply top and bottom of it, the other fraction with it, knowing I have to distribute that 3 through the top here. I'm going to take this third 2 that is not in common over here, and I'm going to multiply top and bottom of the other fraction with that, knowing I have to distribute it through here. So now that I have this work, I'm going to go ahead and I'm going to rewrite this now as 3 times x plus 5 plus, and I'm going to move this 2 over here, 2 times x minus 3. This is going to all be over 2 times 2 times 2 times 3, 2 times 2 times 2 times 3. We'll keep that there in case we can simplify. 3x, or 3 times x, 3x. 3 times 5 is 15, plus 2x, 2 times x is 2x. 2 times negative 3 is negative 6. And that's going to be over 2 times 2 times 2 times 3. When I clean this up and I consolidate, I have 3x plus 2x. That's 5x. 15 minus 6 is going to be plus 9. Now, 5x plus 9, there's nothing that can be factored from that. 9 is not prime. 5 is, but there's no common factors to these. So we'll go ahead and consolidate. This will be 2 times 2 is 4, times 2 is 8, times 3 is 24. So we have our final answer simplified. When we add these two fractions together, we will get 5x plus 9 over 24. So let's go ahead and we'll take a look at some other questions that require a little more aggressive type factoring. Let's go ahead and take a look at 18. We're building out the skill set in this very slowly because this slowly increases in difficulty. So the next question we're going to look at is going to be a plus 4 over 16a plus 3a plus 4 over 4a squared. So in this next problem, we're going to go ahead and we're going to factor these in the simplest possible form. And let's see what happens with this. We'll do this up here. A plus 4. 16 is 2 times 2 times 2 times 2 times a plus 3a plus 4 over 2 times 2 times a times a. 4 is 2 times 2. A squared is a times a. So I'm going to take a look again, see what factors I have in common. I could pick these twos. That's fine. I could do that. And then we have an a here and an a here that's in common. So here I have an a that's a factor that's not here. So I can multiply the top and bottom of this first fraction by a. Here we have a pair of 2's, 2 times 2. So I can multiply the top and bottom of this fraction either by 2 times 2, or maybe more simply the product of 2 times 2, which is 4. So I'm going to go ahead and multiply these factors that aren't over here together, make it 4, and I'm going to multiply the top and bottom of this fraction by 4. Bear in mind again, we need to distribute a through here. We need to distribute 4 through here. So now, let's continue our work. So now we're going to have the quantity of a from here times a plus 4 plus, let's put the 4 over here, times 3a plus 4. What is this all going to be over? We have, let's see, 2 times 2 times 2 times 2 times a times a. 4 2's and 2 a's here. Let's make sure this is the same. Well, that's 4 times 2 times 2 times a times a. So we'll write it out as 2 times 2 times 2 times 2 times a times a. If you wrote it out, this is 2 2's, or you kept the 4, made it 4 times 2 times 2, you can do that. Just, be aware that you may need these factors later on. So that's why I'm keeping this as simple as possible right here. So we have a times a. That'll be a to the second. A times 4 will be plus 4a. 4 times 3a will be plus 12a. Then 4 times 4 will be plus 16. This is all going to be over 2 times 2 times 2 times 2 times a times a. When I want to simplify this, I will, let's see, I can combine what I can here. So I get a squared plus 4a plus 12a is 16a plus 16. And this is going to be over 2 times 2 times 2, so this will be over 16a squared. The reason I decided to consolidate it at this point is I can look here and see that there's no common factor. Can this be factored further? Yes. No, actually, no, I take that back. This cannot be factored any further. This is done. We can't factor this into binomials of any kind. So this problem is a done deal. We're done with 18. So let's take a look at a few more questions that can get a little trickier, especially as we get with multivariables. So let's take a look now at question 24. We have 4x plus 2t over 3xt squared minus 5x minus 3t over x squared t. Take your smart pills before viewing this question. This one is not going to be hard, but it will be tricky. If you apply the same technique that I've shown you up to this point, this question is really not bad. It's a question of technique and being consistent with how you approach your questions. So let's go forward. I'm going to write all the factors here. I'm going to write all the factors here. 4x plus 2t over 3 times x times t minus 5x minus 3t over x times t. Again, I read out each denominator in its simplest form so that I can consider what factors are in common. So we can compare and notice that there's an x and a t that's in common. And when we look at this, we'll identify that here's a second factor in x that's not in common with over here. So I'm going to multiply the top and bottom of this fraction by x. Put parentheses around the top because it's a binomial. I need to distribute that x through. We see here we have a 3 and a t as two factors not in common over here. So I'm going to take the product of these, being 3t, and I'm going to multiply the top and bottom of the other fraction by 3t. Again, distributing it through the top and bottom. So watch something here. Here is a negative. Watch how I'm going to handle this, and you can use this technique as this will work kind of nicely. So I'm going to go ahead and rewrite the numerator now with the following adjustment. This will be x times 4x plus 2t. I'm going to write the minus now. I'm going to go ahead and bring this 3 term in here. Minus 3t times 5x minus 3t. And when I distribute the negative 3t through here, this will take care of the minus sign that's part of the problem. And this is going to be over 3 times x times t times t. We're going to keep that. And see if there's any simplifying we can do later. First, I'm going to distribute x through the parentheses up to this point. Later, I'm going to distribute negative 3t through the parentheses up to here. Let's see what happens with that now. So I have x times 4x is 4x squared. X times 2t will be 2xt. Watch signs now. We're not only going to distribute the 3t, but the negative through, thus switching the signs on the inside. So by distributing it through, it has the same effect of making it addition and switching the signs. Just cleaner. Negative 3t times positive 5x will be negative 15xt. And then negative 3t times negative 3t will be plus 9t squared. So after we have that, we can now divide this by 3x t. Now we can combine whatever like terms we can combine on top. This will give us 4x squared plus 2xt minus 15xt. That should give us negative 13xt. And that's going to be plus 9t squared. And that's going to be over, well, let's see. Now, at this point, you may look at this. This would be a fairly advanced problem. You very well may be able to factor this into two binomial factors. You may be able to. But consider what's in the denominator. We have 3x squared, t squared. If you did get two binomial factors, there's no binomial to reduce with in the denominator. Therefore, there's no good reason to go ahead and even try to factor this. So again, these may have two binomial factors as a trinomial. It wouldn't be a pleasant binomial to factor, but it may have factors. But since there's nothing to reduce with in the denominator, it's not necessary to look at factoring the numerator. And this would be our final answer in simplest form. So when looking to do this question, we have to factor the denominator in its simplest form, identify the factors that are in common, and then use the factors that are not to multiply the other fractions. So let's go forward and look at some questions that may contain some common binomial factors and maybe some binomial factors that aren't in common. So we're going to go ahead and let's take a look now at question 32. We have 3 over 2t squared minus 2t minus 5 over 2t minus 2. So let's see what happens with the factoring in this question and go from there. So what I can do with this problem here is I can go ahead and I can factor out the greatest common factor of 2t. When I do so, that's going to give me a factor of t minus 1. Over here in the second problem, if I factor out a 2, that's going to give me 2 times t minus 1. So this is the first time now that we're seeing common binomial factors. And let's take a look at this. And actually, I think this may work out to be a type 2 problem. Well, let's consider. We have t minus 1. We have 2. So everything that's a factor in the second fraction is a factor in the first. The first fraction, however, does have an additional t that's not a factor in the second one. So we're looking out on this one. This isn't exactly a type 3 problem. So a good thing to note about this one is because only one fraction has an in common factor, we need to take this t and multiply the other fraction by it. So it's just clean, and it's a nicer problem than having two fractions that have unlike factors in the denominator in both of them that we have to multiply both by. But anyway, So we're going to multiply only this one by t. So let's take a look now. So we've got 3 minus 5 times t over, I'm going to write this just as it is here, 2t times t minus 1. And it doesn't look like that we can do anything with the top at all. We can't factor, we really can't simplify it. So we can leave the answer exactly in this form. And that's all we're going to do with this problem. So let's take a look at another problem, something similar to this, and we'll see what happens with it. Take a look at question 36. Or no, we already did 36, so I'm going to go ahead and retract that one. Let's take a look at question 42. We have 4a over 5a minus 10 plus 3a over 10a minus 20. So again here, we're going to take a look, and from the first denominator here, we're going to go ahead and factor out a 5 to get a minus 5 times a minus 2. From the second one here, we're going to have 3a. Now we can factor out, and I'm going to go ahead and do that, make this 10 times a minus 2, because from 10a minus 20, the greatest common factor is 10. I'm going to go ahead and further rewrite it though as 2 times 5 times a minus 2. The reason I'm doing that is when I'm comparing these two, I see a common factor of a minus 2. I see a common factor of 5, but I have a common factor of 2 I have a factor of 2 that's not common over here. Therefore, I need to multiply the top and bottom by 2 over here. So again, here's an example where only one fraction contains an uncommon factor. It's this one. So we're going to multiply the top and bottom of the other one by it to simplify this. So what we're going to get here is 2 times 4a, which is 8a, plus 3a. And we're going to go ahead and leave this. We can write this as, 2 times 5 times a minus 2. Well, 8a plus 3a is 11a. And we'll just make this 10, because nothing's going to reduce now. So we have 11a over 10 times a minus 2. This is in its simplified form. So now let's begin to take a look at problems which are going to be a little more, dare I say, robust. Because now we're going to look at common binomial factors and uncommon binomial factors in these questions. So no messing around with the easy stuff. 46. This is going to be x over x squared plus 2x plus 1 plus 1 over x squared plus 5x plus 4. Now, in these questions, you're going to notice I'm going to go straight to the pair of binomials. I'm not going to show the techniques of factoring for this. My focus is not teaching you to factor for these lessons. My focus is showing you how to identify the common factors in the denominator, identifying the non-common factors, and how to get the denominators to be equal. And then what do you do from there? Okay. So when I write out the factors for the denominator here, these will be listed as x plus 1 times x plus 1 plus 4x squared plus 5x plus 4. These factors are going to be x plus 4 times x plus 1. So now I have in the denominator only binomial factors. They do have a common binomial factor of x plus 1. Each denominator also contains a binomial factor that's not in common. How do I handle that? I'm going to take the uncommon factor of x plus 1. I'm going to multiply the top and bottom by it. So over here in the second fraction, I now have an x plus 4 that's not in common with anything over here. So I'm going to take the top and bottom and multiply it by that. So let's consolidate this together a little bit. So I'm going to have basically x plus 4 times x plus 1 times x plus 1. On the top, I'm going to have x times x plus 4 plus 1 times x plus 1. And yes, I know 1 times this will be the same thing. That's okay. Multiplying this together, this is going to give me x squared. X times 4 is plus 4x. And then plus x plus 1 over, and I keep writing the denominator because this is the proper form. Yes, it's extra work, but it is proper form. So when I consolidate this together, I get x squared plus 5x plus 1 over x plus 4 times x plus 1 times x plus 1. Now, in the case of 46 here, there is nothing that simplifies. The only thing we might be able to do, and the one thing you may need to show when you're doing this work in MyMathLab, is to rewrite this as x squared plus 5x plus 1 over x plus 4 times x plus 1 quantity squared. So, again, what's the focus here? In the bottom now, we're looking at problems like this. The only factors we're getting in the bottom now are going to be binomial factors. Sometimes the binomial factors will be in common, and sometimes they won't, in which case we'll need to multiply the other fractions by binomials and make that happen. Let's take a look at one more problem like this, and then we're going to take a look at some problems that have some tricks that I will teach you how to handle nicely. So let's take a look at 48. Here we have x over x squared plus 9x plus 20 minus 4 over x squared plus 5x. Oops. I said it should give me minus, cross this out, minus 2 over x squared plus 3x plus 2. Sorry about this. When you're looking at your book on the side of you, it's easy when you have a bunch of problems down to confuse things as they all look real similar. So it's x over x squared. You know what? I'm going to go ahead and just start this question again. My apologies for this. Let me just start from the beginning here. This will be x over x squared plus 5x plus 6 minus 2 over x squared plus 3x plus 2. So what we're going to do here is I'm going to factor the denominators, and let's see what we get. So I can rewrite these two factors as x plus 2 times x plus 3 minus 2 over x plus 2 times x plus 1. Again, I know I do the factoring fast. Some of you will see it. Others may struggle with that idea. That's okay. If you struggle with it, please look in the section in Chapter 6 on factoring. The focus, again, is how we work this out. So, identifying the common factors, we have x plus 2 as a common factor, and each of these has a factor that's not in common with the other. So, I'm taking the x plus 3 here and multiplying the top and bottom of the other fraction by it. I'm going to go ahead and take the x plus 1 here and multiply the top and bottom by that. So, I'm going to go ahead and rewrite this problem now. So, we'll do this as follows. We now have x times x plus 1 minus 2 times x plus 3. And this is all going to be over x plus 1 times, x plus 2 times x plus 3. When I consolidate this in the top together, x times x is x squared x times 1 is x. Negative 2 times x would be negative 2x. Negative 2 times positive 3 would be negative 6. So let's just kind of simplify this. This would be x squared minus x minus 6 over x plus 1 times x plus 2 times x plus 3. I see here I have a binomial or a trinomial on the top. Yes, I can factor it. And when I write it as x minus 3 times x plus 2 over x plus 1 times x plus 2 times x plus 3, I notice that yes, factoring this result is going to yield me a binomial factor at top and bottom that I can reduce, giving me a final result of x minus 3 over x plus 1 times x plus 3, giving me my final answer to this question. And this was, again, question number 48. So these questions do involve some work. They are a little entailed, and there is lots of room for error. There'll be one last lesson in this section on how to handle specific types of factoring, particularly involving a negative, coming up.